Hello YouTube! Now, recently I was writing some code and I encountered this really strange bug. So basically what I was doing in a nutshell is I was trying to write a simple Sudoku solver. It doesn't actually get the job done, it just tries to brute force it and it fails most of the time. But that's not the key point. Anyway, to really simplify the issue, I had a line of code that will try to fill in stuff on a particular square, and basically for each pass of the algorithm, that code had to run once for every single square on the board. If you gave my program a relatively simple puzzle, it was able to actually go through and fill in most of the squares in the first pass. So that code was actually running fine. I did some tweaks, and the next thing I realized is, for every pass, it only tried to fill in a few squares and moved on. So I was really confused what was going on. I actually went in to see the code execution, and I realized that my particular function wasn't called at all after a while. Turns out this wasn't a problem because of a bug in my code. The issue is in, Java trying to actually optimize the running of my code that actually caused parts of my code to not run. So after this very lengthy anecdote, let us now properly jump into the episode on logic short-circuiting.
This is 0612 TV.
Welcome aboard.
Hello once again and welcome to this episode on logic short-circuiting. Now, for the benefit of those viewers who aren't actually coders, let's talk a little bit first about conditional statements. When you're writing code, chances are you write code that looks like this. If a particular condition is true, then do the code in the curly brackets. Obviously the inverse also holds. If that condition is not true, then don't do the code in the curly braces. So what is this condition? In general, this condition would be something like a comparison. For example, if x equals 0, then do something, or if y is less than a certain value, then do something. So yeah, that is a very simplified look at conditional statements, basically the way to write code that reacts differently based on different values. So we've just seen very simple conditional statements. Sometimes, practically, we might want to do a little more than that. For example, what if we need to check multiple variables at the same time? We could say something that looks like this. If x equals to 0 and y is more than 1, then do something. So of course, this symbol in the center, the double ampersand symbol, means AND. And in other words, both of these conditions have to be true before the entire thing is considered true and the code runs. As long as either one of these two things are not true, basically the whole thing evaluates to false and the code inside does not run. So very intuitive stuff. We can do the same for OR as well. If we only need any one of these two conditions to be true, then we'll put in the double bar symbol. As you would expect, as long as any one of these subconditions evaluate to true, the entire statement evaluates to true as well. So I hope you're still following me. It's not extremely complicated stuff, but this is where the fun part comes in. Take a look at this particular piece of code. I know it looks a little bit complex, but it does have a significant meaning. Let's take x and y to be the position of an object, let's say a ball. Basically what this code is doing is it's checking to make sure that the ball stays within a predefined set of coordinates. In this case, we want to constrain the position of this ball to 0 to 100, both vertically and horizontally. And basically, this conditional statement will actually run if the ball ever exceeds any one of these bounds. So let's take a closer look at the actual statement. If x is less than 0, or x is more than 100, or y is less than 0, or y is more than 100. Basically, we're checking four things. If at any point of time any one of these things evaluate to true, then the entire statement evaluates to true and we have to run the code inside the curly brackets. Now, every time we try to evaluate one of these subconditions, we spend a little bit of processor power in doing that. If we have a very long statement and we want to execute the entire statement from start to finish, that would mean doing a lot of things and taking a lot of time. Obviously, when we're speaking in practical terms of, our fast processors of today, you probably won't feel the pinch, but let's just say we want to optimize things. We want things to be fast, we don't want to do unnecessary work. So let's say right now that the x position of the ball, in other words its horizontal location, is less than 0. In other words, it has exceeded the bounds in that horizontal sense. So we know the first value to be true. Do we really need to evaluate the rest of the statement? Now, note that because this entire condition is actually subconditions strung together by the OR operation, what this means is as long as we're sure that one of these subconditions are true, the entire statement must evaluate to true. I don't even have to go in and look at the other subconditions. I mean, just think about this. Even if all the other conditions evaluate to false, because the first term is true, the entire statement is true anyway. So why waste computational power to actually compute the rest of the subconditions? We don't have to. We see that the first item is true, and we just jump right into running the code. We don't care about the rest of the conditions. This, ladies and gentlemen, is logical short-circuiting. Obviously, if the first term evaluates to false, then we have to continue doing the work. At any point of time, if any of the terms evaluate to true, we can stop basically checking the rest of the terms, because we don't have to. The same condition applies for an AND statement as well. If any one of the elements is false, then the entire statement will become false, because the AND statement wants every single subcondition to be true before the final output is true. As a result, logical short-circuiting can kick in this sense as well. And there you have it. That is logical short-circuiting in a nutshell. Back to my original anecdote. Well, the issue was because I actually had a line that looked like this. I checked a particular Boolean variable and then did an OR statement with my function. So this Boolean variable is just a variable to hold either true or false. So basically, instead of evaluating a subcondition, we just look at the value of the variable and, well, we already have true or false on our hands. Now, every time my code actually ran, it set this variable to true. And as a result, the next time we went in and hit this line again, this first variable evaluates to true. And as a result, because of logical short-circuiting, well, Java just never got to my statement that says run my code. It just says, oh, this is true, I can move on. And that was how an optimization actually broke my code and made it run even more times. So yeah, basically, that wraps it up for this episode on logical short-circuiting. I hope you learned something, I hope you enjoyed that anecdote. Thanks so much for watching, I'll see you guys next time. Hello, thanks so much for watching. I hope you enjoyed this video, and if you did, remember that I appreciate every like, favorite, and comment you give me. If you'd like to see more from me in the future, don't forget to subscribe to this channel. And for more updates outside of YouTube, don't forget to follow me on Twitter at 0612TV. Once again, thank you very much for watching, and I'll see you guys next time.